Jim Holt, When Einstein Walked with Gödel, Excursions to the Edge of Thought. Embark on a journey into the brilliant minds of two great thinkers, Albert Einstein and Kurt Gödel, as they delve into the nature of reality, time, and the universe in Jim Holt's When Einstein Walked with Gödel, Excursions to the Edge of Thought. This summary explores the transformative friendship between these two intellectual giants, from their meetings at Princeton to their shared questioning of quantum mechanics. Uncover Gödel's groundbreaking conclusions about space, time, and the possibility of time travel, as well as fascinating insights into the nature of mathematics, the challenges of string theory, and the potential fates of the universe.
Einstein's unlikely friendship. Albert Einstein's isolation in his later years led to a strange but fruitful friendship with Kurt Gödel, a genius logician. Albert Einstein, the iconic German-born physicist, forever changed how we understand the world with his groundbreaking papers in 1905. However, few people know that toward the end of his life, he found an unlikely walking companion in Kurt Gödel, a much younger genius logician. In 1933, Einstein fled to the US and settled in Princeton, where he spent his days going on long, solitary walks around the campus. However, he found an intellectual connection in Gödel, who challenged the notion of absolute knowledge with his incompleteness theorems. Despite their personality differences, the two men shared a belief that mathematics was rooted in physical reality and a skepticism of quantum mechanics. Gödel's star was shining brighter than ever while Einstein's star was fading due to his opposition to quantum mechanics. But their friendship brought new ideas, as Gödel took Einstein's famous relativity theory even further. The strange but fruitful friendship between Einstein and Gödel shows that even geniuses need companionship and intellectual stimulation in their later years. The absurdity of time. Einstein's theory of relativity and Gödel's interpretation of it challenge our understanding of time and the universe. In the early 20th century, physicists believed that the laws of physics were absolute and the speed of light was consistent for everyone and everywhere. However, Einstein's theory of relativity debunked these concepts and suggested that space and time could be relative. What Einstein proposed meant that the distances and times measured by two observers in motion relative to each other must appear to be different, despite the speed of light remaining constant. Gödel, who was a brilliant mathematician, took Einstein's theory further and theorized that the universe rotates instead of expands. Such rotation would make it theoretically possible to travel back in time. Gödel concluded that if time travel is mathematically possible, then time itself doesn't exist, making our concept of it an illusion. Einstein's theory upset many scientists who initially refused to accept it. Despite the opposition, experiments conducted since Einstein's time have shown that he was right. However, even today, we don't entirely understand time and its role in the universe. We are still grappling with concepts such as black holes and time travel. Gödel's own tragic end adds to the mystery surrounding the subject. Gödel grew increasingly paranoid after Einstein's death and eventually stopped eating until he died of self-starvation. His interpretation of relativity theory posits that time itself is impossible, making his own time on Earth an illusion. Einstein and Gödel's theories, which may seem abstract, challenge our fundamental beliefs about the universe and our existence within it. Their work pushes us to question our understanding of time and reality and remains relevant today. The music of numbers. The brain is wired for numbers, and even those who struggle with math have a basic number sense that allows them to estimate and add objects in their environment. The Riemann-Zeta conjecture, which holds the key to understanding prime number distribution, remains unsolved but is so beloved by mathematicians that they often assume its truth in calculations. The beauty of pure mathematics. Pure mathematics is about finding beautiful proofs rather than practical solutions to real-world problems. Mathematicians search for simplicity, strangeness, and inevitability in a theory to measure its beauty. Beauty is often equated with truth, and it is more about painting a compelling picture using the language of mathematics. Benoit Mandelbrot's fractal geometry is an example of the beauty of pure mathematics. Certain physical structures are self-similar, or fractal, making it possible to achieve complex fractal patterns from simple formulas. The puzzling nature of infinity. Humans have always been fascinated by the concept of infinity. The idea of endless space, time, and numbers has intrigued people throughout history. Infinity can be infinitely big, almost mystical, or the infinitely small, which is equally perplexing. Mathematicians of ancient Greece used infinitely small fractions to calculate geometric shapes and volumes, but the idea of infinitely small quantities was rejected by most scientists for centuries. Blaise Pascal and Isaac Newton briefly revived the concept in the 17th century, but Newton believed it to be a well-founded fiction in mathematics. It was not until the 1960s that mathematician Abraham Robinson was able to rehabilitate the idea of the infinitesimal, proving its logical consistency and satisfying the standards of modern mathematics. Today, we know that atoms can be divided into electrons, protons, and neutrons, and even quarks may be divisible into smaller particles. The universe may be both infinitely big and infinitely small, making infinity a concept that does not come in just one size. Alan Turing, a mysterious death. Alan Turing, the father of modern computer science, died under mysterious circumstances. He was responsible for cracking the code of the Enigma machine during World War II, which proved to be a huge help to the British forces in winning the war. Turing's abstract computing devices were dubbed Turing machines, and he put his theoretical ideas about computation to the test during the war. After the war, he settled down in Manchester where he was persecuted for being gay, which led to his chemical castration. 2 years later, he died under mysterious circumstances, allegedly from eating an apple laced with cyanide. Many believe he was killed because he knew too much, but his death was ruled as suicide. Despite being pardoned by the British Queen in 2013, the mystery surrounding his death remains unsolved. String theory, the possibilities and complications. String theory combines the principles of general relativity and quantum mechanics by proposing that the smallest elements of our world are vibrating strings of energy. However, the theory requires at least 9 spatial dimensions and has led to complications and criticism. M-theory was proposed to address some of the flaws, but there is still no empirical way to prove the theory's correctness. Despite this, string theory remains a popular explanation for the working of the universe due to the lack of a better alternative. The possible end of the universe. The universe's beginning is widely agreed upon, it began with the Big Bang. However, the way it will end is still a widely debated topic. There are 3 competing theories on how it will all end: the Big Chill, the Big Crunch, and the Big Crack-up. The Big Chill proposes that the expansion of the universe will continue indefinitely until all particles of the universe are spread too far for life to exist. This theory introduces a scenario where conscious entities, or Boltzmann brains, are able to emerge in the universe's chilled state. The Big Crunch theory suggests that the universe's expansion will stop, and it will start collapsing back onto itself, driving the production of a remarkable amount of energy. The Big Crack-up is based on the notion that the universe is expanding faster and faster, leading to the decay of protons, and the dissolution of matter. The Copernican principle suggests that humanity won't likely witness any of these theories' possibilities.
In When Einstein Walked with Gödel, Jim Holt takes us on a captivating journey into the minds of groundbreaking thinkers whose revolutionary theories rewrote our understanding of space, time, and reality. At the heart of the story is the intellectual kinship of 2 very different men, Einstein and Gödel, who shared doubts about quantum mechanics and held a deep conviction in the physical reality of mathematics. As you explore their intertwined lives and their impact on science and society, you'll encounter captivating ideas, such as Gödel's proposal that time is an illusion, our innate number sense, the tantalizing beauty of pure mathematics, and the mysterious nature of infinity. The book leaves us to ponder the infinite possibilities of knowledge and awareness in the vast expanse of the universe.